Hello again. Today we're going to take some steps towards looking into AI and neural networks. So we're going to start off simple and see how far we get. This is part one, and hopefully there'll be quite a few more parts to come. So let's begin. So let's first assume that we have some given data. So this is data plotted using the function y equals x squared, but we're going to assume that we do not know the relationship between the independent variable and the dependent variable, and this is just given data. So we want to figure out the relationship, and we decide to model this relationship as some linear combination of a polynomial, fourth degree polynomial, and the functions sine x, cos x, and e to the x. We randomly guess an initial estimate with random weights to our linear combination, and here's our guess with initially random weights giving us the green graph, which is doing well to estimate our data in the middle, but towards the sides falls off with large errors here. Okay, but we try to optimize our weights by iterating through them, adjusting our weights. So we take some small epsilon step and we iteratively look at our weights, change our weights by plus epsilon and minus epsilon, and determine whether that gives a better error than our current estimate, and if it does, we adjust our weight, and if it doesn't, we keep our weight the same. So this is essentially finding the direction to which we should take our weights that would result in reduced error. So sort of what this gradient slope method. And as part of the function, if we ever get to a point where moving our weights by epsilon doesn't really help us improve our error, we will attempt to remedy that by reducing the size of our epsilon. Okay, so by taking finer estimates. So having a look at the results of this iteration process for 100 runs, we have that our initial data is in blue there, and initial estimate is green as before, and we see our latest estimate number 100 in red, much more closely estimating our given data there. And our initial error was 451.58 after 100 iterations, and optimizing our weights, we have a latest error of 24.34, and this is our current estimate for the relationship between x and y. So this is our current linear combination. And here we look at the error. So error very quickly falling off in the initial iterations, and after that error getting smaller, but to at a much slower rate. So our initial estimates give us the greatest benefit, and then after that we're just refining little by little. So in an attempt to visualize the process, we have this plot, which again has our given data, initial estimate, and our final estimate, but we also have these gray lines, which are the estimates in between the initial and the final, so just some of them plotted out. So we see here from the initial downward bending estimate, our curve kept just getting a little bit better, trying to curve more into the x squared shape until it actually became more of a even degreed polynomial. And as well, I did the same thing this side, just with more data points to give a finer plot, or just smoother plot. So there we have our initial estimate, and here it's plotted again with our final estimate or latest estimate in red, and error plot there. And for the visualization, there we have our gray interim estimates. We also, in addition, have a slightly nicer plot with weights on the side, our final weights, and a bit of an animation here. Just restart this. So our estimate number here and the weights and error as they change. And okay, that's that for the first part. Thank you.